Hello everyone, welcome to ACE Maths. In this video, we are going to understand fractional indices. Many students find this topic confusing, but I want to show you that it's actually very logical. Fractional indices are not a new rule, they follow the same rule of indices you already know. So let's start this discussion with a already established fact that the laws of indices also apply when the index is a fraction. Alright, so let's take this example. Here we have x raised to the power 1 over 2 multiplied by x raised to the power 1 over 2. So this is an example of fractional indices. So from the laws of indices, we already know that whenever we are multiplying and the base is same, we keep the base as it is and then we add the powers. So that gives me x. 1 over 2 plus 1 over 2 is 1. So we have x raised to the power 1, that is nothing but x. Now we can ask ourselves this question: what is x raised to the power 1 over 2? Now let's ask ourselves what number multiplied by itself gives x. We know that root x or square root of x multiplied by square root of x gives x. That is the definition of square root of x, right? But from the previous example, we saw that when we multiply x raised to the power 1 over 2 with itself, we also get an x, right? That's what we saw in the previous example. We multiplied x raised to the power 1 over 2 with itself and we got an x. So it means that this x raised to the power 1 over 2 is nothing but square root of x. So this is not a new rule. This is just a new way of writing roots. So we can understand here that the fractional index means root. So the fractional index is just a new way to write roots. Let's do the same with cube roots, right? So here we have y raised to the power 1 over 3 multiplied by the same 3 times. So from the laws of indices, we know that whenever the base is same and we are multiplying, we keep the base as it is and we add all the powers. So I will add 1 over 3 times. This will be y raised to the power 3 over 3. 3 over 3 is 1 and y raised to the power 1 is y. Now let's ask ourselves what number multiplied by itself 3 times give y. I think you have guessed it correctly. That is nothing but the cube root of y. If we multiply the cube root of y with itself 3 times, then we get y. That is the definition of cube root of y. But from this example, we just saw that if we multiply y raised to the power 1 over 3 times, we also get y. So it means that this y raised to the power 1 over 3 must be equal to cube root of y. Again, this is not a new rule. This is just a new way of writing roots, because fractional index means root. So now we can arrive at a general form. Look carefully. We have x raised to the power 1 over n, and I have written it as the nth root of x, or x radical n. So let's take few examples. Let's try to answer. We have y raised to the power 1 over 4. Can you guess how can we write it in the radical form? Yes, that would be the fourth root of y, or y radical 4. What about a raised to the power 1 over 8? I think you have guessed it correctly. It would be the eighth root of a, or a radical 8. So this is the general form of the root and index conversion. We can convert any root to the index form or vice versa. Now let's solve some questions. Write in index notation. In the first example, we have square root of 90. Square root of 90 is nothing but 90 raised to the power 1 over 2. The second question is cube root of 64. Cube root of 64 would be 64 raised to the power 1 over 3. Now this one is x minus 2 radical 5, or the fifth root of x minus 2. In index notation, it would be x minus 2 raised to the power of 1 over 5. Fourth question says the cth root of a over b, or a over b radical c. So in index notation, it would be a over b raised to the power 1 over c. Now let's talk about non-unit fractional indices. Non-unit fractions are the fractions where the numerator is greater than 1. So these are some examples. We have 2 over 3 or 3 over 4. So clearly here the numerator is 2, that is clearly greater than 1. Here we have 3, 3 is greater than 1. So these are some examples of non-unit fractions. Now let's take our very first example. We have x raised to the power 2 over 3. 2 over 3 is a non-unit fraction. So we have a non-unit fractional index. This 2 over 3 can be written as 1 over 3 multiplied by 2. So if I apply that logic here, I can write it as x raised to the power 1 over 3 multiplied by 2. And from the laws of indices, especially power of a power, I can rearrange the powers like this, right? Because we know that whenever we have power of a power, we can simply multiply the powers, keeping the base same. So this is just the reverse of that rule. Here the powers are being multiplied by each other. So I have kept this 1 over 3 inside the bracket and I have put this 2 outside. Eventually these powers will be multiplied and we will get x raised to the power 2 over 3. Now let's talk about the next step. The next step, here we have x raised to the power 1 over 3, all raised to the power of 2, that is basically x raised to the power 2 over 3. Now let's first take the cube root, because we have x raised to the power of 1 over 3. So that is basically cube root, right? So let me take the cube root, that is the cube root, and there is this squared present outside the bracket. Or I can write this as cube root of x squared. Both forms are correct in examination. You can write this in both ways. So let's move to the second example. We have y raised to the power of 3 over 4. I can write this as y raised to the power 1 over 4 multiplied by 3. Why? Because this 3 by 4 can be written as 1 over 4 multiplied by 3. Now, from the laws of indices, I can write this as y raised to the power 1 over 4 whole cubed. Now, let's take the fourth root first. So it would be the fourth root of y raised to the power of 3. Again, I can write this in a different way. I can write this as fourth root of y cube. So both forms are correct. Now, if we look closely to both the examples that we just solved, we can see that whenever we convert the index to the root, the denominator becomes the root and the numerator becomes the power. So look carefully to the first example that we just solved. So x raised to the power 2 over 3 became cube root of x squared. Now, here the numerator was 2. This 2 actually contributed to become the power, and we had 3 as the denominator, and this 3 became the root. Similarly, in the second example, we had y raised to the power 3 over 4 and it became fourth root of y whole cubed. Now look carefully, we had 3 as the numerator. This 3 became the power and we had 4 as the denominator. This became the root. So that is why the index root conversion guide says that the denominator becomes the root and the numerator becomes the power. It helps us to solve such questions with ease. Now, let's take few examples. We have a raised to the power of 5 over 7 and we need to convert it into the root form. So convert it to the root form, we need to look at the numerator and the denominator. We know that the denominator becomes the root. So let me just make the denominator the root, that is 7, and then the numerator 5 will contribute to become the power. Similarly, in the second example, we have t raised to the power of 2 over 5. 2 is the numerator, so it will become the power, and 5 is the denominator, it will become the root. So we have t, the denominator 5 will become the root, and then we have the numerator, that is 2, and it will become the power. So we can write a general form for x raised to the power m over n. In the root conversion, it will be the nth root of x all raised to the power of m, or there is a different way to write. We have the nth root of x raised to the power m. So to summarize, fractional indices mean roots, the denominator gives the root, and the numerator gives the power. In the next video, we will solve exam style questions on fractional indices. Make sure you are comfortable with these ideas first. Thank you for watching.